Hi, this is Dr. Clyde, and we're on the last step, step 6 of 6, on optimizing your metabolic exercise. We're going to look at the big picture, and then for our finale, narrow down on the importance of regular movement throughout the day, which relates directly to my research at the University of California, San Francisco in biochem biophysics. So I'm excited to tell you a little bit about that. So we started our conversation a half dozen videos ago talking about how strengthening increases the capacity and endurance training, the efficiency. And of course, this is an oversimplified model, but a functional one as a starting point. And now with this conversation that we've had since then, you now realize the importance of a lower versus a higher intensity of each of these. So the higher intensity where there's greater resistance, you can't do 10 repetitions, lower intensity where you can do more than 10 repetitions. And then the endurance side, the higher intensity where you've got the short sprints and the long sprints, and then the lower intensity where you can go for an hour and for greater than an hour. And we've touched on the mechanisms that underlie these different training quartiles, these components of our training zones. And that is that at the higher intensity, we're activating mTOR and satellite cells to increase the engine size. And at the lower intensity, we're increasing the efficiency of fuel use within the neuromuscular system. And then on the cardiovascular side, the endurance side, at the higher intensity, we're burning ATP so fast that we activate adenosine monophosphate kinase, which triggers gene expression for fat burning. And as you ratchet down in intensity, we have different aspects of increasing the efficiency of fuel delivery. So we want efficient delivery, use, and capacity. That is our metabolic flow. So this cartoon I created to demonstrate to you how the different supply components come in. We've got the heart and the lungs delivering cardiovascularly our nutrition and oxygen to keep our system going. Our 10-minute race pace maximizes that delivery. The 1-hour pace triggers through the central nervous system, our autonomic or fight or flight system, to ramp up the fitness adaptation. And when we go to the 1-minute pace, now we're targeting within the muscle, AMPK, to increase fat burning. Now, strengthening adaptation within the muscle is very different for less than 10 repetitions per set, where we're activating the satellite cells, SC, and the mechanistic target of rapamycin, over 10 repetitions per set, where it's shifting in steps towards muscular endurance. Now, higher repetitions done at a high cadence, that maximizes your work output and is your high power, and therefore is burning just as much sugar, generating potentially just as much damage. And so that is your peak intensity. So this image here shows you the whole supply and the demand system. And I added in green the movement throughout the day to keep the muscles idling continuously. These colored dots have a legend up in the upper right. The purple dots are where you're burning mostly sugars. That's sprints and low repetition strength training and fitness training or athletic training or power training. And fats, the darker green, primarily in your 1-hour pace and longer than your 1-hour pace. And then in the light green, which is your 10-minute pace and high repetition strengthening, that's where it's a combination and falling in the spectrum somewhere in between, where you're using both fuel sources potentially equally, right? Fats and cardio. So this cycle here shows how we're feeding from cardiovascular health to your threshold number 2, which is your 1-hour and race pace, 1-hour effort, to your VO2 max, which is your 10-minute effort, to short bursts, which is your less than 3-minute effort, probably peaked adaptation at 1 minute. And so the red arrows show you where you're increasing the supply, but the short bursts, which is still cycling, walking, and swimming, still has the look from an outside observer as cardiovascular exercise, but its effect is on the demand. And then that supply, the red, is feeding into the demand, which is increased with the bursts, with muscular endurance, increased force, and increased power. and then waste clearance, and the system starts again. I put in green within the demand the movement throughout the day, which isn't strength training and isn't even necessarily cardiovascular. This might just be a 10-second effort or a 1-minute effort each hour, or maybe you just contract your muscles in the seat without getting up. So it doesn't even look like exercise to anybody. Some of my students refer to that as the DrClyde clenching technique, to just activate the muscles without moving, just to keep the muscles idling. And that's what I want to share with you in my work with Roger Cook and Armin Naber at UCSF. This is us as the Biophysical Society Conference in 2022, presenting some of our research on this, and our paper that we had just published just over a year before that, where we show that muscle can completely shut down to burn fewer calories by as much as 1,000 per day, likely in response to extreme dieting and being sedentary, where the muscles aren't activated. So when you activate muscles, it pulls them out of this extreme shutdown so they keep idling. You can imagine your muscles like your car idling at a stop sign or a red light, where they're burning calories, but the car's not moving. So it's at rest, but it's burning calories, it's idling. Or it's in your driveway, parked, you pull the key out the ignition, now it's completely shut down. That's super relaxed. And the difference between the fuel burning in your car is dramatic. It goes from greater than 0 to 0, and the muscle is the same. It can idle throughout the day, and if you're overfeeding, your metabolism goes up to try to fight against the weight gain. Of course, inevitably weight will go up if you're overfeeding chronically, and depends on how much. But metabolic rate goes up with overfeeding, and down, resting metabolic, and down with underfeeding. And within a 25% range, the metabolic rate is fairly stable. But if you're overfeeding by more than 25% or underfeeding by more than 25%, that's where the super relaxed state will, particularly on the underfeeding component, fight against your weight loss. It will drop your resting metabolic rate by close to 1,000 calories. And there are observational studies, 6-year follow-up with Biggest Loser contestants, where they did really hard exercise and dieting, where 6 years later, they still have a suppressed metabolic rate of 800 calories a day. Imagine having to eat 800 calories less than what you would have needed to 6 years earlier, just to not go up in weight because your metabolic rate is so far suppressed. There is no other system in the body that can drop in the metabolic rate by 800, 900,000 calories a day without becoming dysfunctional. Even the brain uses less than 600 calories a day. Heart, lungs, kidneys, these organ systems use anywhere from 200, 250 calories a day. There's no system that can shut down by 1,000 calories a day other than skeletal muscle. And you don't even know that it's in the super relaxed state. If you're sitting on a couch, sedentary for extended periods of time, and burning no calories in muscle, as soon as a twitch comes through to get up, you get up like a normal person. You have no idea that you were in the super relaxed state on the couch, as opposed to if you're just dieting by 25%, not inducing the super relaxed state, the muscles are idling more. Now you're on the couch burning calories. You don't know that either. So this works against us by confounding metabolic targets that we're after, where we think we can cut calories more and more and more and lose weight, but the body ends up just working against us. And if we're trying to gain healthy weight, and I've worked with athletes that fall into this category where they're eating more and it's hard for them to gain healthy weight, to get up to where they're wanting to for the soccer field or to become a pro tennis player. And so the healthy weight loss and the healthy weight gain have to take into account the super relaxed state. So a car parked with key out the ignition, that's super relaxed. If it's idling at a stop sign or red light, now it's burning calories. And then once you push down on the gas, now you're burning even more. So the super relaxed state helps explain the decrease in metabolism seen with people trying to lose weight too fast, or where they're skipping meals for too long a period at a stretch and they're losing muscle mass, and it's going to the super relaxed state at the same time. So double trouble. It also helps explain the increase in metabolism seen after brief movement. And that's called excess post-exercise oxygen consumption. So if you activate all your muscles right now, maximum voluntary contraction for 10 seconds, and then you release, your muscles will keep idling for as long as a whole hour afterwards, burning more calories, even though you're not activating your muscles anymore, just because it pulled your motor proteins out of being attached to each other, frozen in place in the super relaxed state. So now they're flopping around, searching. This is called, you're potentiating twitch potentiation. So every time you activate your muscles, it'll pull whatever motor proteins are in the super relaxed state out. So if you don't do a warm-up in strength training, you'll notice that on the first repetition, you're weaker, and then all of a sudden you're stronger. That's because there were motor proteins in the super relaxed state that had to come out after the first twitch. So this is called twitch potentiation. So what works for warming up in strength training also applies to activating your muscles periodically when you're sedentary. And I'm including standing as being sedentary, because I could stand here and my legs falling asleep and not do much for 5 hours, and I'm mostly in the super relaxed state. And so this improves blood lipids and glucose parameters more than exercise when you're comparing by a calorie equivalent. So a 30-minute workout once a day, as opposed to 1 to 3 minute activity breaks, the same total amount of calories through the day, 30 minutes as opposed to broken up into 10 3-minute activity breaks. You have more idling for more hours after the activity breaks. The workout only has one idling period afterwards, only one epoch, excess post-exercise oxygen consumption. So here's a study that looks at sitting and then a half-hour walk, or 2-minute walk every 30 minutes, total half hour. So same total calorie burn during the activity itself. Now here's the red block is the 30-minute walk, and this thick black line on top is the small amount of idling afterwards that's burning calories. If you have the walks broken up throughout the day, so the same total half hour, this is the yellow block, but it's broken up throughout the day, then the idling after each short walk ends up doubling or more the total calorie burn. And if you do both, then it's the same. So your extra calories from idling comes from the short walks, not from the long one. So idling throughout the day to burn more calories, raising your resting metabolic rate, doesn't come from the workout. It comes from the movement throughout the day. And so in type 2 diabetics, if they move, they take an activity break every hour as opposed to every half hour, as opposed to every quarter hour, the more frequently that they do it, they lower the blood sugar rise from each of their meals, the insulin response, and the total glucose area under the curve. They are dramatically improving their glycemic response, their body's ability to manage their food by having frequent muscle activation. It doesn't have to be a workout. You don't even have to think of it as an activity break. Think of it as a postural adjustment, like the Hadza, the modern day hunter-gatherers. And so here's another study where they're doing a 3-minute walking or light strengthening, like body weight squats, just slow body weight squats, not super intense, doing several of those throughout the day. And you can see how their blood sugar is normalized, whether it's the light strengthening movement or the walking, blue and green respectively. They basically lie on top of each other. They're normoglycemic through the day and through the night, as opposed to hyperglycemic in response to those meals. So this has an extended positive impact even outside of the meals themselves. In this study, they show how oxygen and therefore fat use is as high with standing up and then sitting down every 20 minutes as it is if you're just standing or just sitting. So when you're sitting, you're burning less, you're using less oxygen. When you're standing, you're burning more. But if you sit half the time and then stand up and then after a while sit down, it's the activation to stand up and sit down that generates most of the oxygen and fat burning, because your muscles keep idling. So sitting is not the new smoking. It's lack of muscle activation that's the new smoking. You can activate your muscles in your chair. You don't have to get up out of the chair. Okay, in summary, we've talked about our system being a supply and demand, where there can be bottlenecks if one thing is missing, that efficiency to fixing this so you have an even metabolic flow is critical, because you can't just hammer your body doing more and more. You cannot benefit from what you can't heal from. And that the metabolic steps are addressed by different training zones of strengthening, endurance, and muscle activation at lower intensity throughout the day. And that specifically endurance training zones are under 3 minutes, 10 minutes for short and long sprints, a 1 hour pace, and a significantly longer than 1 hour pace. There's 4. And for strength training, there's a normal cadence at perfect form, which is power. And then there's higher resistance, less than 10 repetitions, lower resistance at higher than 10 repetitions, and then even greater than that, where you're mixing muscular and cardiovascular endurance together. So each endurance and strengthening have 4 training zones, and that movement beats them both in a calorie per calorie basis, and has a clear clinical benefit for those who are at high metabolic disease risk. This is Dr. Clyde, and I look forward to seeing you in my other 3 courses.